Welcome to Fire Engineering's Training Minutes. My name is Paul Dansbach. Today we're looking at a building under renovation. The original building was a 1.5-story platform-framed, wood-frame, single-family dwelling. The type of construction, or the construction vernacular for this type of building, was referred to as a Cape Cod style dwelling. Construction terminologies and styles are somewhat regional and will vary from different parts of the country. In the Northeast, the Cape Cod style home is rather popular. The renovation of this building has taken the original platform frame building at 1.5 stories to a 2.5-story building that uses lightweight i-joists for the floor systems. The second floor and the third floor systems are both constructed with i-joists. We're going to go inside and take a look at the renovation to identify the structural components and to talk more about the fire characteristics of lightweight i-joist floors. We're in the first floor of the house under renovation. As we look up, we'll notice that the original second floor floor joists have been removed and replaced with I-beams or i-joists. The i-joists bear on the back wall of the house, the seawall of the house. The bearing surface for the i-joist is the top 2x4 plate. As we move towards the front of the house, toward the A wall, we notice that halfway through the house there is a laminated beam. The i-joists are attached to the laminated beam through the use of a joist hanger. The joist hangers is a dissimilar material. It's steel. The joist hangers are going to be quickly damaged by a fire. The connection point at the laminated beam is not as secure of a connection at the seawall where the i-joist, the bottom of the i-joist, bears on the top plate of the 2x4 wall. We're up on the second floor of the house. As we notice, the third floor floor joists are also i-joists. The i-joists span from the A wall to the C wall with a bearing wall about halfway between the A wall and the C wall. One of the ways firefighters can tell what walls, interior walls, are bearing walls versus non-bearing walls is the direction of the floor joists. As we notice, our i-joists cross over the bearing wall at a 90-degree angle to the wall. We'll show you a non-bearing wall. A non-bearing wall runs parallel to the i-joist or floor joist. If we follow our floor joist back to the A side of the building, we notice that our i-joists bear on a 2x4 top plate. Directly below the 2x4 top plate is a header for a window opening. The header delivers the load imposed upon the 2x4 top plate. It takes that load horizontally, transmits the load to the 2x4 stud wall, which carries the load down through the structure. So far, we've looked at the second floor and the third floor of the building. Both floors are constructed with i-joists. Next, we're going to look up onto the third floor at the roof system. The roof rafters are constructed with dimensional lumber. It looks like the roof rafters are constructed with 2x10s. There is a tremendous difference in the way i-joist versus true dimensional lumber performs under fire conditions. We're going to talk about that in a little bit. We're outside. We're at the sea wall. As we talked about before, the i-joists for the second floor bear on the sea wall. The i-joists are cantilevered about 2 feet or so beyond the sea bearing wall. There is another potential for fire extension with this construction feature. If fire vents out this window, it exposes the underside of the soffit material. If the soffit material does not offer a fire barrier, fire will extend beyond the soffit material and into the combustible void space created by the i-joists. Fire then has access in that combustible void space running from the C wall all the way to the A wall in the structure. What we've talked about in this session of training minutes is a house under renovation. We've looked at the floor systems. The original floor system of this structure was dimensional lumber. It was a 2x10. The floor systems that have been added to the second and third floor are i-joists. It's an engineered structural element. sometimes referred to as a lightweight I-joists or lightweight construction. What it really comes down to is mass. Fire resistiveness and collapse resistiveness of any wood frame building is a function of mass. How much is there to burn before the structural component reaches its yield point and fails? As we see with the dimensional lumber, there's a significant amount of mass. With our I-joist, the I-joists lack mass. The web of the I-joist will quickly be attacked by fire and will lead to a quick collapse of the floor assembly. Thank you for watching this session of Fire Engineering's Training Minutes.